This lesson, not too difficult. We're back to our friend calculus. Our favourite part of maths. Derivative, integration, it's all wonderful. So now we're going to have a look at some integration. So we talked a good bit about how to differentiate. And we have 4 new ways to differentiate. We have the product rule, the quotient rule, the chain rule, and implicit derivatives. And these 4 methods kind of let us differentiate anything. So any function we can imagine, we can now differentiate using these 4 methods. So if there's no function we cannot differentiate. The situation is a bit different for integration. There isn't nice rules like product, quotient, and chain for integration. Unfortunately, integration is much harder to do than differentiation. But we do have some methods, and the first method is called substitution. So suppose I have something like this. X e x squared dx. I want to integrate something like this. Now, if I said differentiate it, that would be easy peasy. What rules would I need to differentiate this? Product and chain. Do we have such a thing for integration? We do not. We have a different method called substitution, which you can probably guess from the name. You substitute, you replace. So you say let u equal, and this is the key step, what do you make u equal to? Yeah, for these problems you make u equal to x squared. That means, what does du dx equal? 2x. So that means, what does dx equal? It would equal du over 2x. So this result, with this result, will simplify the problem greatly. The problem now becomes integrate x e u du over 2x. We are not allowed to mix x and u. But that's not a problem here, because what happens? They cancel out anyways. Yeah. So you're left with a half integrate EU du, which is a half EU plus C. Although we don't want u, we want x. So this will be a half E x squared plus C. And that is the answer. Now they get harder than this, but write this down as our first example. You've seen this method before? No. You have, Sean? Ah, Jerry. Continue? What? Ah, what's taking you so long, Jerry? No, right, go on. No, right, just quickly, right, come on.
Go.
No, go, quickly, Jerry, just go. I'll drink some coffee, okay? Sean is still writing as well. Okay. No, it looks like you took a picture. You might break something valuable, be careful. I'm talking about the wall, of course. Finish, Sean?
Yeah.
Yep, okay, continue?
Yeah.
Right, I want you to try this one, and I'll give you a hint for it. I want you to integrate tan x dx. And my hint is 2 hints. Hint number 1 is to remember that tan x is equal to sine x over cos x. And hint number 2 is to let u equal cos x. Okay, give that a try, see what happens. And you know what? I'll just not that it's too drastic, but you know, tan x, there's a problem at pi over 2. So just to prevent any kind of problems here, I'm just going to say x is between 0 and it's smaller than pi over 2. So you don't have to worry about anything with tan now. Got an answer? What did you get? No. No. Tis not true. Tis false. Any answers over here? Minus sine x. That's quite wrong. Oh, minus sine x squared. No.
What?
No. We have 3 different answers. None of them right. Anyone want to give me a 4th answer? Minus du? No.
Minus cosine.
No. Is it? Is it? Is it? Ready to see?
No.
Okay. Nobody's gotten it right yet.
Negative log cos x.
This sounds right.
Sounds right.
I think it's this.
Where is the log?
Yeah. The reason he has log is because he has the right answer. Let's have a look. So, this equals sine x over cos x. I think you all agree on that. And if we said u is cos x, then what's du dx? Minus sine x. So what does dx equal? Du over minus sine x. I put that together with that back in here, and I get integrate sine x over u du over minus sine x. Cancel, cancel, and that's minus 1 over u du, which equals minus log u plus c, which equals minus log cos x plus c.
Like minus integral sec
What are you talking about, dude?
x du equal to.
Huh? I don't know what you're talking about.
I just said the
This is the right answer, I promise you. And I'll just remind us that this is when x is between 0 and pi over 2.
Can we integrate the sine x?
What you talking about? You just did. There's tan x, you integrate, and that's the answer.
Without converting into sine x over cos x?
No. No. This is the only method to integrate tan x, because I don't think there's a rule. I don't know. I might be wrong, but I don't think there's a rule in the formula book for integrating tan x. There's a rule for differentiating tan x. It's 1 over cos squared. but I'm not sure if the integration of tan x is in the book. You can check it later. I mean, there's a chance it might be. Any questions on this? So, Jerry, what did you do wrong?
Everything.
Okay, great. KJ, did you get this? Almost, Monica? Yeah, you just left it as 1 over u. I thought so, yeah. Sean, I think your mistake was here.
Yeah.
Mm-hmm.
Do you know why we can put the minus in front of the x?
Why not?
Why? Why we can't?
What did you tell him in English, please? I want to know.
I don't know.
What did he tell you?
I don't know.
The number can
Yeah. Here, look. This, and this,
equal.
they're all the same.
I know, but why we can put minus in front of the x?
Ah, here.
Yeah.
Like, take it out.
Yeah.
Okay, because if you remember, I said if you have this, you can do this. Factor out. Because I said this it's like brackets. You can take constants out. Yeah, it's called linear. You're allowed to take constants out in front. Yeah?
Yeah.
Question.
I did it this way.
Ah, well that's fine.
But
I understand what you mean now. No, wait! I'll show you how to change it into that answer. So you can change this into log cos x minus 1 plus c, which is log 1 over cos x plus c, which is log sec x plus c.
Yeah, I put...
Fine, both answers are fine.
Okay.
Yep. So you can do this, or this. What is sec? Oh, we haven't done that yet. We'll do that later. Some people know what it is. It's 1 over cos x. We will do that when we get back to trigonometry. Okay, continue.
Yeah.
Okay, you getting the idea? Yeah, actually, hang on. Yeah. I suppose if I said integrate tan t dt, the answer would be log sec t plus c. Better? Alright. Try this one. Integrate, let's see. 1 plus x over 1 minus x dx. X does not equal 1, and my hint is, well, what do you think I might tell you to use for u? 1 minus x, actually, yeah. Okay, try to integrate this, please. You got the answer right?
No.
What you get, KJ? Are you not finished yet? Minus 2 plus 2x. That's it? Oh, that sounds wrong. Because that's linear. What's the derivative of a linear? Constant. And this isn't constant. This function is definitely not constant. Skateboarding today? Oh, what happened? The weather was raining, wasn't it? Might get electrocuted. Yes. Skateboard with an umbrella. No. How are we doing over here now? Lee, Sean, you have answers? You have a weird answer. What did you get?
Minus
Don't know. Monica, what did you get? What did you get?
Minus x squared over 2 plus log 1 minus x plus
You had a log in it. I believe there should be a log in the answer. Yeah. Let's have a look. So, u equals 1 minus x. What does du dx equal?
minus 1.
So what does dx equal?
minus du.
Okay, so that and that goes into there, and this becomes integrate 1 plus x over u minus du,
Yes.
which becomes minus integrate 1 plus x over u
Yes.
du. But what is the problem here? Yeah, we can't mix x and u, but x, well, maybe in a moment, yeah, x equals 1 minus u. From here, I can say this. X is 1 minus u. So I can change this into integrate 1 plus 1 minus u over u du. So now I get minus integrate 2 minus u over u du, which equals integrate u minus 2 over u du, if I put the minus back in, which integrates u over u minus 2 over u du, which is integrate 1 minus 2 over u du, which is 1 minus 2 log u plus c, which is 1 minus 2 log 1 minus x plus c. That is the answer. I don't quite think you got that, Lee, did you?
No.
Yeah. Did anybody get that?
I got over u minus 2 over u du.
But did you get to here?
No.
What went wrong?
u minus 2 over u. I canceled u.
KJ!
If I didn't, I got correct.
Do you know what this word is? That's a sin. You go straight to hell for doing that. Okay, we're writing this down. I hope we're getting the idea. Yeah. In the exam, they sometimes tell you what to use for the u, sometimes they don't. Now my only tip for what to use for the u is, usually what's on the inside or in the denominator, in the bottom.
Teacher,
Yeah.
why is 1 integrate into 1? Isn't that u?
Oh my goodness! Bad teacher, bad. I'm so sorry. That should have been a u, which means my answer should have been minus x minus 2 log 1 minus x plus c. Apologies. Any smart guy here can tell me why I didn't bother to write in the
1.
the 1? Yeah, I wrote minus x. I didn't write 1 minus x here. Any smart guy can tell me why?
Oh, I see.
Yeah, what about it? You're right. What's the reason exactly?
You don't care.
Close. Yeah, we don't care because it's just part of C.
Oh. Can we write it though?
Yes. It's fine.
I mean,
Why do you?
that's confusing.
Yeah, but think about the energy I save not writing that extra 1. If you really wanted to, you could even write it like this. Minus x plus log 1 over 1 minus x squared plus c, if you really wanted to. But I don't think you do. And anyways, I think this is easier.
Can you do that with calculator?
No, this can only be done on the calculator if you provide limits. Then the calculator can do it. Otherwise it can't. Well, I maybe spoke too soon. Can that integrate, KJ?
So the range of the integral is infinity to infinity, right?
No. Oh, you mean what values can you use? Oh, well, there are no
If I want to put on the calculator, if I put like...
No. This is indeterminate. It's there's no limits, so there's just no limits provided. Not that the limits are infinite. Just there's no limits provided. Yeah. It can integrate. And what way did it give the answer?
So minus bracket 2 and then absolute x minus 1 absolute plus x.
It sounds like the signs are backwards. Let's try my calculator. And we'll see which calculator is better.
Gosh.
Right. Let's see. Now, KJ's point is, on his calculator, it's trying to deal with the fact that this can't be negative. So I'll deal with that by simply saying in my question to begin with, I'll just say, I'll just say 1 minus x should be positive. So I'll just say x is smaller than 1. And it can't equal 1 because we don't want to divide by 0. So I'll just say x is smaller than 1 in the question. Right, let's see what I have here. Integrate 1 plus x over 1 minus x. Oh, and can I say, what is it, x less than 1? Can I do both? No, can't do both. Alright, integrate minus 2 log x minus 1, 1 minus x plus c. Now the reason it flipped it around to x minus 1 is it doesn't know what values of x I can use. So in this picture it's saying as long as x minus 1 is positive. So the computer solved it but it assumed that at the beginning x should be bigger than 1. It had to make some choice here at the end, because I didn't tell it anything about x. Now, if I open up this program, called the internet, let's see what I get using Wolfram Alpha's website.
No Casio man anymore for it.
Casio needs limits.
That's
No, it's a good calculator. It's not a graphing calculator. Right. What's the website called? Wolfram Alpha, I think. I think I showed you this website in semester 1, didn't I? Wolfram Alpha integrals. Integrate. Right, integrate, come on dudes. Oh, I have to type. Integrate 1 plus x over 1 minus x, where x is less than 1. Oh, whoops! I just saw that. I never wrote my forward slash. There we go. Try again. Is it loading?
It can't do it.
It can do it, believe. It's just loading, that's all. Right, let's see now.
No result.
Okay.
Hold on. Where's the integrate? Did I not understand my x? Yeah. Minus x minus 2 log 1 minus x minus 2 log 1 minus x plus constant. Boom. It is a nice program. So it's right. Yeah. Grand, we're happy with that.
What is a below?
The below one is just the value if x goes to infinity. This becomes minus 1.
I mean double.
This is if you want to expand it as a series. A bit like, 1 over 1 minus x was a long series. That's the derivative of it, by the way. What rule would you need to differentiate this? Quotient rule? Look, it gives you the domain. The domain is everything except 1. It gives you the range. The range is everything except minus 1. It gives you the root. You see, very nice, very nice. So if you just type in fact, I think if you just type in the function, it should do everything. It should give you the domain, the range, the derivative, the integration. Oh no, I have to give it a verb. I have to give it a verb. Yeah. Okay. Can you try these for a couple of minutes and then we'll finish? Can I close this now?